Thank you so much. And I love this. I love the fact that I'm able to join as part of this interdisciplinary and truly intercontinental discussion here, bringing people from all around the world. That's really amazing. And I love to be part of communities like this. This talk is entitled Embrace Context, How to Love the Messy, Raw, Shifting, Imprecise World We Live in, and Teach Machines to Do the Same. So I want to give a quick bit of context on myself. I run what we call a human-centered AI firm. We build AI technology for some of the world's most recognizable brands. And our focus is really on making these products both intuitive, meaningful, usable, but also equitable, fair, safe, transparent, non-biased, and so forth. So we really take that goal and that mandate onto ourselves in everything we do. Now, of course, this is much easier said than done. And that's why I feel that firms like ours really play a crucial role in this modern knowledge-based economy, sharing our insights and our knowledge across industries and domains. But I will say outright here that this is mostly a theoretical talk. And I have a number of different talks that I've given, some of which are more tangible and much more specific, with lots of visuals and lots of screens. But for this conversation, I really wanted to provide maybe only a stark few examples, but most of this will be a dialogue. And I want you to sort of bear with me in some cases, as some of these things might be sort of unfamiliar or they might be more conceptual. But I think that what we can emerge out of this conversation with is a much deeper understanding of intelligence as a whole. And I think that that's really the key to unlocking these notions around artificial intelligence, drawing the connections between our own intelligence and how we perceive and understand the world to then how do we encode those kinds of ideas into machines. So to motivate this discussion, let me pose what I would consider a seemingly simple question. What does it mean for one to build a well-designed AI? I'd ask this question to every one of my students on the first day of their course. And actually I ask this question at every workshop that I ever facilitate on this topic. Now, such a simple question elicits quite a diversity of answers. And I would say even some serious head scratching. So on one hand, a well-designed AI seems relatively straightforward. It's no different from any other kind of well-designed thing. But on the other hand, it also seems to call into question the role of the designer at all. There's this temporary cognitive dissonance between the goal of an AI system and the need for such systems to, in a sense, decide for themselves. However, one thing that we do know is that at present, most of our AI systems do not seem to be, in many cases, well designed, at least not yet. So why is that? Well, let me just give a series of vignettes of what I've seen to be happening within the AI field. So experts in the computer vision space have finally begun to start discussing the problem of unstaged environments for computer vision algorithms, which to me calls into question the premise of staging and why is staging even required for intelligence in the first place. NLP experts have begun to wonder whether there is indeed a conceptual solution to the problem of English to Mandarin translation, which most bilingual speakers would still admit is quite early, and perhaps in need of an alternative approach in general. Reinforcement learning researchers have begun to look at the prospect of real-world use of their systems with some dismay, where it's clear that there are immense, perhaps even paradigmatic challenges around domain awareness and safety critical systems. And finally, modern large-scale machine learning architectures have begun to ingest inconceivable amounts of data. And instead of what we imagined would be awareness, these systems have actually gained a thirst for reproducing dominant cultural narratives. So in all these situations, a kind of connective tissue has emerged with these disparate systems. In this thread, there's sort of this unresolved rupture between the concepts underlying AI technology and the messiness and chaos of our multimodal lived experiences. So we believe that the solution lies in context. Context should be seen as the penumbra to intelligence, the glow around it. It is the environment around intelligence that gives it meaning and gives it purpose. So what is this perhaps mysterious term, this splinter, this catch-all that feels so inelegant, so non-general? Is it this our project of knowledge extractivism? Is it not the sum total of context in general? Are we not imbuing our systems with all the context that we possess, every situation, every moment in our world? So is there not some core pattern that these systems should be able to extract, some core reason that's embedded within this data itself that can be abstracted and then represented. Why do we need context? In fact, I think we must place the concept of context very sharply into focus if we're to make serious inroads into the concept of human-centered intelligence. I personally think that this should be the fulcrum of a new generation of design of intelligent machines. So let's start by understanding what I mean by context and how does it play a part in large-scale machine learning systems. So this includes kind of a variety of machine learning architectures. This includes BERT, this includes computer vision, this includes document processing and awareness in general of information. They all share this kind of crucial key architecture, right? You have this general English language corpus in the case of language, but it could be a general vision corpus in the case of computer vision, such as object detection or autonomous vehicles. In these systems, we have this corpus that spans all kinds of domains, and those domains really are incomprehensibly large. So if you look at the domain that was given to modern day systems such as GPT-3, you see that it includes websites, recipes, blogs, lists, books, Q&A articles, truly an incomprehensible amount of information. It's certainly greater than the amount of information that a single person could ever read, but it's also probably perhaps 1,000,000 times greater than that. It's the sum total of an entire society's artifacts, its representations, the information that it's created. Now, contained within this library is a full, what seems to be a full domain exploration of every concept, all regions on the globe, all words in the English language. The aspiration behind this corpus is that we've comprehensively explored the entirety of what it means to speak English. It embodies a belief in some ways that all this knowledge is equal, that every text has equivalent value, equivalent weight. Really, starting with the belief in a sort of democracy of information. Now, however, using a process of massive energy consumption and massive computation, this data is processed through a paradigm of machine learning. It yields a highly complex matrix of parameters, at this point on the order of trillions of numbers. We then finally interact with this quite immense system through what I would consider a fairly astonishingly simple interface, a text editor. The system simply generates text. You push a button and out come words. Whatever the model chooses, it can write. Now, immediately we run into a problem. We realize the fundamental limitation of this entire paradigm, this entire process of knowledge extractivism. We realize the need for context. So what is context? Context is really the tiny amount of information that you input into the system to yield intelligence, right? Intelligence is not available to us without that tiny amount of context that we have to input into the system. So I'd encourage any of you to use one of these kind of transformer-based architectures, these natural language systems, and talk to it, type text into it, see what text it outputs. When understanding and appreciating these interfaces and sort of the exploration of text, you also realize the significant limitation. You realize that the information that you enter into the system colors and really structures the output. So what you're seeing is that you're not actually seeing pure intelligence. You're seeing intelligence as it's guided by the context that you enter into the system. To me, this feels like a kind of a crucial paradox, an irony that's embedded deep inside of these architectures. In essence, they are too general purpose for their own good. In digesting all those millions of textual documents, the sum total of human knowledge, they lose the kind of narrow and focused purpose that's actually quintessential to solving real problems. In addition, what comes out of these systems is not just pure knowledge. They tend to make the dominant tenor, style, personality, beliefs more apparent in everything that they do. Their outlook is colored by the sort of will of the greatest number. What these systems lack is good, meaningful context. It's an understanding of the problems at hand, and it's an understanding of the needs and desires of what we want out of these systems. So how can it really be in this context here, or in this framing of the problem, that literally 10 characters typed into a text box are more important than trillions and trillions of letters input into this machine learning system? How can this paradox sit with us as designers of this new kind of technology who understand the need for context? Well, some of you might be saying, that kind of context, this conversation around this is quite inane, right? All you're saying is you need to add more data to these systems, additional information, additional words and beliefs in order to generate other meaningful beliefs. But to that, I would say that's actually not true. Of course, a system with more data will have more intelligence, will have a higher quantity of information, but let us actually pause to consider that context is not simply about adding more data. In fact, context is not something that can actually be reduced to a simple mere quantity. Take this example of an image labeling AI. On the top left here, we have ImageNet, the sort of famous image database upon which there are over 10,000 labels. For each image has a label of a certain object. On the bottom, we have a comparatively much smaller data set, a data set of just cars and trucks, right? And in both cases, we can actually formulate the same conceptual problem to the AI. On the top, you can say, I want to know whether this picture is of a car, is it a picture of a truck, or because there's many other labels, you can just say none of the above or none. On the bottom, you can say, is it a car or is it a truck? Now, the paradox that you will see here is that you can provide the top left system, the AI that is trained on ImageNet, you can give it an order of magnitude more parameters, you can give it an order of magnitude more compute power, you can give it an order of magnitude more data. And yet the system on the bottom, the smaller and leaner system, purely with awareness of a particular domain, will fare better at solving this problem. So to me, I find this to be a huge paradox, and it flies in the face of everything that we seem to be learning and we seem to be experiencing from a surface level understanding of the AI community. So to me, it goes by different names. You can call it prompt design, you can call it fine tuning, you can call it data curation, you can call it giving the system guardrails, domain knowledge. You can also call it user interface. You can call it interface design or interaction design. And in all case, I think what we're really exploring here is just the power of context. Now, despite the dominant narrative within the AI industry, context is not a dirty secret. It's rather what I would call a secret sauce. It's the act of allowing the AI to learn not just from internal representations of data, but from external stimuli. It's not simply a matter of feeding the model more data. It can also imply reducing or filtering the input data. But in all these cases, we're not demanding this kind of illusion of omnipotence, right? We're admitting that all knowledge is fundamentally limited as an end in itself. And what we care about is an understanding of the problem, an understanding of the situation, lived experience. Now, let me provide just 3 examples of how leveraging context, even within the last year or within the last 5 years, can explain why certain kinds of AIs have become more successful and they've actually been able to enter the market and provide meaningful value, whereas some of the AI that are supposedly general purpose or domain free have not. So looking at in the first example, Google's Derm Assist app, announced only a few weeks ago, we can see that despite their best efforts, Google has indeed embraced context here. The system demands that users take not just 1, but 3 pictures of their skin condition before this AI app can provide them an automated assessment of whether that's a skin lesion or perhaps cancer. Now, clearly, I would argue that this was not optimal to Google. It was certainly not their first option. If they could have worked from 1 photo, right, and it would be unquestionably more powerful in their eyes. It would be unquestionably more useful to them. Instead, what they realized is that by adding more data to the system, by adding more examples of your skin condition, they were allowing the user to provide additional context, in this case, 3 pictures. And in this case, the 3 pictures are enough to force the system to ignore things like background data or badly staged photos. Now, this is precisely what I meant in my book, Lingua Franca, when I spoke of variadic AI. Something that can take more than 1 data point in order to make a decision. And I think for designers, this really speaks to the crucial element of interaction design in terms of adding and displaying and providing context. In Apple's Music app, released in 2015, the users presented with a quiz before being able to browse for songs, being able to receive recommendations. Now, this quiz is a kind of context gathering design paradigm. it asks the user to provide more details about what they like. By adding this additional context, the entire user experience simply becomes better. The user finds that the app is more personalized, more meaningful, and just by learning from user behavior might have been a more elegant solution where you simply open the app and you can it starts to learn from what you're browsing. But if the user immediately quits within 30 seconds, within a minute of using this application, what good is all of that AI anyways? Finally, in the Neuralink demo that we might have witnessed earlier this year, the team was able to learn a representation of a monkey's brain in order to accomplish what they thought was a surprising feat, playing Pong with its mind. What they didn't say, though, is that the system required 6 entire weeks of context gathering before it was able to make this interaction possible. A totally AI-driven system, one might believe, wouldn't need this context. It should already know and already have the information available to it in order to control a mind. However, what we see is that this context is so important to the system, that this context gathering process is so meaningful, that systems simply cannot function without it. Now, interestingly, there is a concrete neurological basis for the primacy of context. We must always remember that as humans, we are not individual automatons expressing our agencies solely in the lifeless, static world. We exist steeped in culture, history, and our own evolutionary pasts. Much of what we deem as intelligent behavior exists fundamentally outside of our capacity to reason. So let's take an example, one of my favorite ones from an old book, Claude Lévi-Strauss's La Pensée Sauvage, of the pre-scientific society. The pre-scientific society now, without an intimate understanding of chemistry, has nonetheless identified common features of many poisonous plants. How is that? They use factors such as colors, taste, and smells to develop a comprehensive working theory. Now, one might say, let's simply take an AI and allow it to do the same. But the relevant context is, of course, the vast evolutionary history, the inbuilt human faculty for sense that we've evolved over many millions of years to make the task easier for our minds. By giving potential toxins within fruits and veggies and within flowers a bitter taste, the brain has already built within it a highly sensitive, though highly imprecise, classification algorithm. The conscious agent, the mind, or the intelligence in our case, is then able to use this faculty along with a range of contextual clues that might vary even across individuals, across societies, or entire eras of human society. In this case, neither the mind nor the faculty for taste have a complete representation of the world. Neither possess its intelligence in isolation. The more context you give to a system, the more useful it becomes. And I think this should really become the mantra of every designer. Give the AI context, question broad claims, make the user interaction more nuanced, more domain specific, strive to understand the particulars of the situation. Do not be content with general purpose systems. Design for edge cases. In fact, the more edge cases, the better. Use different models for different communities. An AI that works in the US might not work in an African context. Question standardized or general purpose data sets. Design your own data set. Customize everything. Be wary of pre-labeled data or worker-labeled data and embed yourself within the problem and the community that experiences it. So why is it that we seem to have a distaste for context and a thirst for abstraction? Why is it that we want ever more general purpose systems that consume ever more data and provide ever simpler and less complex, less contextual user interfaces? In a sense, the way we've built traditional computer programs today mirrors the underlying physical construction of computers and machines themselves: logic, programming, memory. The bare minimum form of abstraction within a computer is not the transistor or even the binary bit, but in fact the logic gate, in which one or more input signals are given to create a related output signal. Now, the key principle behind this is the notion of abstraction. These logic gates are used to construct processors that do arithmetic. This arithmetic is then abstracted away into modules that comprise an operating system, which itself allows users to program, and then those are used to construct higher level applications and so on ad infinitum. Now, hackers have long known that the basis of many successful exploits of software lie in taking advantage of leaky abstractions. In the buffer overflow exploit, a program unknowingly writes to memory that it does not own therefore destroying the abstraction and opening the door to chaos. It's therefore not surprising to me that abstraction itself and the fear of breaking abstractions are deeply ingrained into the core ethos of software architecture. However, when we enter the realm of the brain and the mind, we need to question this abstraction, this separation of concerns. We need to be wary of the assumption that the mind thinks in separable rational spheres. We can take the pithiest of pithy examples here. Ask yourself the question, what is 2 + 2? Of course, the mathematical answer 4 would immediately come to mind. It would not seem to result, however, from a computation. The brain does not need to compute 2 + 2. It actually, the answer tends to pop into our existence inside of our mental workspace. Additionally, one might immediately visualize in their head not simply the answer, but the entire equation. In fact, they might see the image of themselves writing on a blackboard the numbers 2 + 2 = 4. It's much more than this mere mathematical representation. The question might also bring to mind subtle feelings. It may actually cause you to subvocalize, silently speak the statement out loud. It might cause you to temporarily have visualizations, drawings, imagery. It might cause some people a geometrical vision. And to folks who have certain forms of synesthesia, they might literally actually see colors when seeing this equation. Moreover, the question has connotations. It is connected to the brain's ability to form memories. It might bring to mind our notion of youth, of child's play, of classrooms, of playgrounds. It might bring to mind the early days of interacting with one's own children, perhaps a particular moment or a particular experience. So as this simple example shows, the brain does not compartmentalize its inner workings into distinct categories, abstractions, or functions. If one were to attempt to measure the time it takes between a person hearing this question and generating an answer, that time could not be linked to a simple set of causes or causality or particular pathways of thought. We have to realize and we have to accept that cognition is in essence an unstructured phenomenon. Even as as simple a question of whether we compute math is today unknown to even the most highly advanced sciences and neurology. Now, the very existence of math as a discipline makes it clear that a brain is not actually required in order to do this calculation. We do not need a trillion dendrites and axons and millions of years of human evolutionary history in order to create a system that can answer the question 2 + 2. However, there does seem to exist a broader phenomenology around decisions than just abstract categories and beliefs. Our brains are deeply entangled, and the elements of our brains do not operate in isolation. In the book Surfaces and Essences, Douglas Hofstadter and Alexander Sander write, generally speaking, context has a great influence on categorization. For example, an object can slip in the blink of an eye from the category chair to that of a stool when a light bulb has just burned out and one needs something to stand on in order to change it. Our categories in our lives are fluid, but the way that we train our AIs are with strict and absolute labels. Without better context, therefore, these labels will always be missing some meaning. Our labels and categories err because machines lack the nuance of understanding the intrinsic fuzziness of any label. Modern AI theorists have recently begun to recognize this and show that such label bias can have disastrous consequences. Let's take the example of gender. An algorithm trained on data of just 2 labels, 2 genders, male and female, will forcibly place individuals into strict bins that mirror our social biases. But to this we might say, let's say 2 is not enough, but then what quantity is? Now, labels themselves devoid of context seem to generate and structure the reality around us, obscuring the uncertainty that lies fundamentally at the margins of our thought. Our brains are designed not simply to construct or to live within abstractions, to live within categories, but to create them. And such problems, in my mind, will not be solved with just endlessly complicated, algorithmically fair AI. I believe that the key to overcoming these problems is to leverage context. So finally, as our lives are transformed by AI, we need a class of what I would say AI designers or contextual designers or bricoleurs that take advantage of context itself. Designers that see the messiness of the real world and embrace it and do not abstract it away. designers that can make AI not for its own sake, but for the vast and complex communities that we live in. Thank you. That's my talk.